All right, so this is 2, 6, which was the combining functions, right? Like adding, subtracting, multiplying, dividing, and then the composite functions. So at the top, you're given f of x is 3x minus 1, and g of x is x squared plus 2x minus 1. So if I have f plus g of negative 1, this time I didn't say f plus g of x and then f plus g of negative 1. So remember, you have those two choices. I can either take and combine these two together. So I could do 3x minus 1 plus x squared plus 2x minus 1, combine my like terms, and then plug in the negative 1. So I'd get 1 minus 5 minus 2, which is negative 4 minus 2, negative 6. I could either do it that way, or I can do f plus f of negative 1. I'm going to do that over here. F of negative 1. All right, so if I do that, I've got f of negative 1, which is 3 times negative 1. I wrote negative x, negative 1 minus 1, which is negative 3 minus 1, which is negative 4. And then I add to that g of negative 1. So negative 1 squared. Man, this does not like my stylus. Negative 1 squared plus 2 times negative 1 plus 1, which is 1 minus 2 plus 1. Oh, this should be a minus 1. Minus 1 at the end. So negative 1 minus 1, which is negative 2. And then I would add these two together, and I get negative 6. So how you choose to do that is completely up to you, okay? If it says to the number, you can go straight to the numbers, or you can add them. You can plug them in and then add them at the end. Oh, let me tell you. All right, the number 2 says f over g, and then find domain. So I'm going to put the f on the top, the g on the bottom. F would be 3x minus 1 over g, x squared plus 2x minus 1. And then find the domain. So the domain, remember, in the denominator, I have to look and see if there's any kind of restriction. So there are factors of negative 1 that sum to positive 2x, not that are factorable, right? If I use the quadratic on this, I would get negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 2 plus and minus the square root of 4 minus 4 times 1 is negative 4 times negative 4 is plus 4 over 2, negative 2 plus and minus the square root of 8 over 2. As soon as I see that that's a real number, I know I have to keep going. Square root of 8 gets reduced to 2 root 2, and then this becomes negative 1 plus and minus root 2. So that's what x cannot equal, which means my interval notation is negative infinity to negative 1 minus root 2. There it goes. Negative 1 plus root 2.
This time, again, the 100s, 400s, and portables should...
Number 3 says f of...
What about everything in between negative 1 minus root 2?
Oh, yeah. Sorry. Trying to focus while they're talking is not an easy thing. This should be end in between. Thank you, Sophia. So u negative 1 minus root 2 to negative 1 plus root 2, union negative 1 plus root 2 to positive infinity. So it's all three of those because it's not equal. So not equal to negative 1. And if it was an I, you wouldn't include it because that's all real numbers. But because there's an actual real number there, you actually need to include it, okay? We are going to see quadratics again, which is why I chose to bring it back in. So just keep in mind that's going to come back into your lesson today and tomorrow. Quadratic formula. All right, f of g of x. So this time I am taking the g and I am plugging it into the f. So I would get 3 times x squared plus 2x minus 1, distribute the 3x squared plus 6x minus 3 minus 1, 3x squared plus 6x minus 4. Now there's no domain restriction on that composite one, and then I have to go back to the g of x, look at that one and see is there a domain restriction there. No, right? No square roots, no fractions, which means my domain on this is all real numbers.
You have to pull it out.
Nope.
And sorry for the interruption. If you did not hear, all freshmen.
All right, then the f of g of -1. Okay, this time we're just dealing with numbers. So I'm going to take the -1 and I'm going to plug it into the g of x. And then I'm going to take that and plug it into the f of x. So if I take -1 and plug it in here, I get -1 squared plus 2 times -1 minus 1. 1 minus 2 minus 1, -1 minus 1, which is -2. And then I'm going to find f of -2. So I get 3 times -2 minus 1, which is -6 minus 1, or -7. And remember, that's not like a two-part answer. The -7 is your answer. That's it. You go all the way to the end, and then that's your answer.
Why'd you multiply by -2?
So I am taking the -2 and plugging it in, because the -2 is the result from g of x, right? So I take that result and I plug it into the f of x.
Oh, okay.
Any questions on the warm-up before we move on to start chapter 3? So some of it is very different, like the composite functions, there's not a lot of that continuing. The thing you will see again is obviously you're going to see the quadratic come back a little bit, but a lot of today and tomorrow is just drawing parabolas and learning how to draw them more accurately than we have already.
So how do you know when it's like not all real numbers?
So if you're looking for a square root or a variable in the denominator. Those rules of domain are for every function. If there's a variable in the square root, I have to say whatever's underneath the square root has to be greater than or equal to 0. If it's in the denominator, it cannot equal 0. And if the both happen, it's greater than 0. So the domain restrictions, if it's in the denominator, right, we say whatever's there can't equal 0. If it's under a square root, we say whatever's there is greater than or equal to 0. And if it's under the square root in the denominator, we say it's greater than 0 instead of greater than or equal to 0. So those domain rules never change.
But what if, so it just says like x plus 8?
All real numbers.
Okay.
X squared plus 8, all real numbers. X cubed plus 8, all real numbers. Cube root of x plus 8, all real numbers.
But then why do we, like, since they have like x squared plus 2x minus 1, why wouldn't that be all real numbers?
Because that's in the denominator. We put it in the denominator when we did f over g. Right? We did f over g. So we took g and we put it in the bottom. So you have to check it after you've combined it, and whatever way you combine it, you have to check that. If it's a composite function, the open dots, you have to check the original one on the right and what you combine. Does that make sense? Okay. This is 4, right? So you want to do f minus g of 3 of t. So did you do f minus g and then plug the 3t in, or did you do f of 3t and then g of 3t?
I just did the f and then the g.
So you did x plus 3 minus x squared minus 2, like that?
Yeah.
And then distribute the negative x squared.
I got negative 3t squared plus 3t plus 5.
Okay, so from this one, wait, so this would be like this, like that, right? Then you got the negative 3t squared plus 3t plus 5. You just have to square this. So it'd be negative 9t squared plus 3t plus 5.
Oh.
That's all.
So why is it negative 9?
So the negative is on the front. Remember when we plug in parentheses, then you do the exponent first and then take the negative. So when you plug in whatever this 3t, what was it, x? We plug into this x. When you plug in parentheses. So 3t is in there. And then the exponent, by order of PEMDAS, the exponent goes first, then the multiplication. So you have to square first and you get 9t, and then negative 1 times 9t. Oh, I'm not showing you my screen. That's really helpful. So because there's an exponent, we do the exponent first, and then negative 1 times 3t squared. So you have to square the 3t first and then take the negative. Mm-hmm. So you got to here, yeah? You didn't square?
Yeah, I got it.
Yeah. So you have to square first, then take the negative. So anytime there's a negative, so like if it said like negative x squared plus 5, this is going to be negative. Because whatever you plug in there stays positive or becomes positive, but then the negative gets multiplied at the end. It's always going to be that negative. All right, so like I said, we're going to break 3-1 down over the next couple of days, okay? It is a long section because there's a lot going on in it. When we are done today, I'm going to show you, like, in the homework, a lot of the questions combine all this stuff together, and we won't get to the beginning part of each question until tomorrow. But you can do a big chunk of the questions, so just remind me before we're done, and I'll go over exactly, like, what it looks like and what you can do of the homework, okay? Again, if you leave 3-1 all for tomorrow, there will be tears because it will be a lot. So we start with the basics of a quadratic function. So we call these parabolas. We know that already, okay? There's two forms of a quadratic function, and the first is quadratic form. That is ax squared plus bx plus c. So in these, you have both an x squared and an x. That's how you know the difference between quadratic and what we're going to talk about in a little bit, which is standard form. In quadratic, you have an x squared and an x in your original equation. This is a parabola, so this is just our parent function, but it's called a parabola. The spot where it changes direction is called the vertex. The variables we use for vertex are hk, but it is just an x and y. If my parabola opens upward, it has a positive x squared. And if it opens downward, it has a negative x squared. So this is a positive x squared one. If it opens upward, it has a minimum. So if it's an x squared, positive, x squared has a minimum. If it were to open facing down, it would have a maximum. Okay? Either case, the min and the max are both the k. So the y coordinate of your vertex is the minimum or the maximum point. And then the axis of symmetry is the line that runs through the center of my parabola in which I fold it over and it overlaps. So axis of symmetry is a line that runs through the vertex where if I fold it over that axis, it is symmetric. This, super important, is an x equals a number. It is an equation. It is not a single number. So if I ask you for an axis of symmetry, which I'll teach you how to do, if I ask you for the axis of symmetry, your answer has to be an equation. It has to be x equals a number, not just the number. Because an axis is not a point, it's a line. Yep. It's always going to be a vertical. Yeah, all of these are functions, so think functions can't turn sideways because then it would fail your vertical line test. So they're always going to be facing up or facing down. It's always going to be a vertical line. It's always going to be an x equals.
So would the axis of symmetry of this one be x equals -1?
Correct. Yep. So the question just was, would the axis of symmetry be x equals -1? The answer is yes. Okay. All right, so if we are graphing an equation that's in quadratic form, which is what we're talking about, then we're going to start by finding the vertex. And to do that, we do negative b over 2a. I get a number from that, I take that number, I plug it back into the x, and I get the y. And then that's going to be my HK. Then I would find the y-intercept. Okay, if that's not enough information, then I would continue to either plug in additional points or use the x-intercepts, because sometimes it will ask for those too. The x-intercepts we will either find by factoring or quadratic, which is why we talked about it already today. So sometimes we can factor, and sometimes we have to use the quadratic. All right, so we're going to start with some really basic ones, okay? This just says to graph. So on the first one, I've got f of x equals 2x squared. The first thing I do is figure out, is this opening upward or downward? Upward. Because that 2 is positive, it opens upward, right? What we should know from our transformations is what kind of shifts are happening. Is it going left or right? No. Is it going up or down? No, so my vertex should be at 0, 0. Does that make sense? That we already know because of our transformations. The only thing that's happening to this graph is it's narrow because of that too. But we're going to find exact points, okay? So if I continue to use the method that we just talked about, that I already know which direction it's going to face, negative b over 2a is going to give me my x coordinate of my vertex. So the a is 2. There is no b, which means b is 0. So I get negative 0 over 2 times 2, which is 0 over 4, which makes sense because we already said we know our x coordinate of our vertex is going to be 0. Take that, plug it back in. Now f of x is the same thing as y, so I say y equals 2 times 0 squared, and y is 0. So again, confirming what we said, that our vertex should be 0, 0. How do I find a y-intercept? What do I plug 0 in for, the x or the y? Good, the x. So if I plug 0 in for x, I already found it, right? The y-intercept is also 0, 0. 1 point is not enough to graph. If I wanted to find the x-intercept, I plug 0 in for in for y. Divide by 2, square root, it's still 0, 0. I still only have 1 point. So in a case like this, you have to plug in additional points. When you graph your parabolas, you want the vertex, you want a point to the right, and you want a point on the left. So I'm going to take a point on the right, like positive 1, and plug it in. 2 times 1 squared would be 2 times 1, which is 2. Now I've got that point. One squared is 1, 2 times 1 should be 2. Oh, which is fine. If you plug in 2, then you're getting 2, 4. It's still a point. You're good. Now we said this is symmetric to my axis. My axis should run through my vertex, right? So if I plug in a point to the left of my vertex, what should my y be? The same, right? They're going to be the same because they're reflexive. So I get, symmetric, 2 times negative 1 squared. 2 times negative 1 is 2 times 1, and that's 2 as well. So if we are correct on our vertex, we can identify our axis of symmetry, and then we actually can save ourselves the time of plotting points. I will be very honest that if I'm taking a test, I'm for sure going to plot the extra point to make sure my first one was right. Because if for some reason, oh, don't move you, go back. If for some reason we plotted, let me undo. The first coordinate point wrong, we would find it by plotting that second coordinate point. So again, you need vertex always, and then you need a point to the right of the vertex and to the left of the vertex. Now the axis of symmetry is running right through my vertex. It is x equals 0. Again, it has to be a line. We found our y-intercept was 0, 0. We found our x-intercept was 0, 0. So all of those things will be asked, okay? What if I asked you domain? So that's your range. Yeah.
Is it all real numbers?
It's all real numbers. Okay, there's no restrictions here. The range 0 to positive infinity. Okay. I could ask you increasing, decreasing on this stuff, right? All that stuff still applies because it's still a graph. So it would be decreasing from negative infinity to 0 and increasing from 0 to positive infinity. It's not like the homework's not going to ask you for increasing or decreasing. Just keep that stuff in mind. No. No, it's going to ask you for the intercept. It's going to ask you for the vertex, the axis symmetry, and then you're going to graph it.
So the negative b over 2a is just for the vertex?
Correct. And that's just the x-axis of the vertex. I mean the x coordinate. Then you plug it back in to get the y.
I'm confused with the y-intercept and the x-intercept part. Like, I know you plug 0 in for it, but...
So, example 2, the same thing's going to happen, but we're going to move forward, and I'll show you what happens different, okay? Like 2 is not going to answer your question yet, Juliana, because it's the same. But when we go to the next one, you'll see it should be different. Okay, so think about what's happening here. 1/2 x squared. There's still no shifts, right? This is going to be wider than my initial one. So I already know the vertex is at 0, 0. If I didn't know that, then I would do negative b. A is still 1/2 here. Not still. A is 1/2. B is still 0 here. So if I didn't know, if I didn't understand the vertex shifts and that kind of stuff, and I did negative, b over 2 times 1/2, I still get 0 over 1, which is still 0. I take and plug that back in, 1/2 0 squared, and it's still 0. So right now my vertex is still at 0, 0, which was the same as the first one, right? If I want to find my y-intercept, I can plug 0 in for x. I already did that. 1/2 0 squared is 0. So my y-intercept is 0, 0. If I want to find my x-intercept, I plug 0 in for y, which is the f of x. 0 equals 1/2 x squared. I'd multiply both sides by 2, and I get 0 equals x squared, square root both sides, and x is still 0. So sometimes your x and y-intercepts are going to help you, and in this case, they do not. That's not giving me any additional information other than I know it's not going to cross the x-axis or the y-axis. So when I plot my initial vertex, which is the only point I have so far, I still have to plug in points to the right and the left because I don't have enough information yet. Sure. So I plug in positive 1, 1/2, positive 1 squared is 1/2 times 1, which is 1/2. And then 1/2 negative 1 squared is 1/2 times 1, which is still 1/2. So I have the 2 points, 1 and 1/2, and negative 1 and 1/2. So this graph is wider than the first one, which is consistent with our shifts that we talked about in the last chapter. If it was a whole number on the front, it was more narrow, and if it was a fraction on the front, it was more wide. My axis of symmetry is again x equals 0, and all the other stuff is also the same. My y-intercept is 0, 0, my x-intercept is 0, 0, domain negative infinity to positive infinity, and range 0 to positive infinity with a bracket on the 0. So these are really a lot of just your parent function with a little bit of variation. All right, so now what do we think is happening with these graphs? They're going to be upside down. That's one thing, right? If I were to compare it to just x squared, what does the 4 on the front do? Makes it skinnier or narrower. What's the 1/4 do? Wider. So take all that stuff and help that, like use that to help you eliminate some of your work, right? So I know this is going to be upside down, and this is also going to be upside down. I know my vertex is going to be at 0, 0. My x-intercept's at 0, 0. My y-intercept's at 0, 0. So I still have to plug in points here. So if I plug in positive 1, 4, negative 4 times positive 1 squared would be negative 4. Plug in negative 1, negative 4, negative 1 squared, and it would be negative 4. So I've got a coordinate point at 0, 0, positive 1, 4, and negative 1, 4. My my axis of symmetry is still x equals 0. My domain is still all real numbers, but how does my range change?
0 to negative.
Other way around, right? So negative infinity to 0. You always want to go smallest first, so the negative comes first. Now all the same is happening for 4, too, okay? My vertex is at 0, 0. I have to plug in a point because my x-intercept, my y-intercept are also going to be at 0. So negative 1/4 times 1 squared, negative 1/4, negative 1 squared is negative 1/4, and then this would be negative 1/4. So now I've got a coordinate point here, and then it goes wider. No worries. So my axis of symmetry is still x equals 0. My x and y intercepts are still 0, 0. My domain is negative infinity to positive infinity, and my range is negative infinity to 0. So notice all the examples we've done so far just have a number on the front. There's nothing after the x squared. Obviously, this stuff starts to change a bit as we move forward. But know that that stuff can help you. Like knowing your parent function and knowing your transformations can definitely help you eliminate some work. Questions before we move on? Okay, so what happens if my equation is in standard form? Standard form means you only have an x squared. Well, you have an x maybe in the parentheses or by itself squared, okay? But you don't have an x squared and an x. In these cases, the vertex you can pull straight from your equation. The vertex is what's the opposite of what follows x, and then what the k is, which is by itself. So if I had f of x equals, and it could be anything on the front, it doesn't even have to be a number there, minus 2 squared plus 5. Let's say this is my equation. Then I change the sign for the x coordinate of my vertex. So my vertex would be a positive 2. Change this sign. And then I keep the sign on the y. And think about why that happens, right? When I look at my graph and I'm doing transformations, if there was something inside the parentheses, where did we shift it? Like if it was positive, we shifted it left. If it was negative, we shifted right. The opposite direction. Does that make sense? But if there was something added or subtracted after, if it was positive, we shifted up. If it was negative, shifted down. So that sign we don't change, but what's in the parentheses is what we change, okay? Then the axis of symmetry is x equals whatever that h is. So my axis of symmetry here would be x equals 2. So all that information I get straight from my equation. I don't have to do any work for that. The additional points is what I'm going to have to do work for.
So for the quadratic, it's always going to be 0, 0 as your vertex?
No, you'll see when we're going to move it around. Yep.
Wait, so the H for the axis of symmetry, you would pull from the vertex or the problem?
Either way, from the problem you change the sign. From the vertex you don't need to because you've already changed it.
Just say it was like x plus 2, the H would be negative 2?
Correct. Yep. Which looks like this. All right, so f of x equals x plus 2 squared minus 3. So the first thing I do, again, figure out which way this is facing, which is what? Up. Okay, that a is there now, and it's a positive 1, which means it's up. Now I find my vertex, which is what? Good. Negative 2, negative 3. Change the sign on what follows the x, but do not change the sign on what follows the y. I mean, what's by itself? What's my axis of symmetry? X equals negative 2. All right, so I already have my first pieces of information. Negative 2, negative 3. And it points up. Now let's see if we can find a y-intercept. So the y-intercept, we're going to plug 0 in for x. So y equals 0 plus 2 squared minus 3. Add the 3. Actually, don't add the 3. Just keep going. Y equals 2 squared minus 3. Y equals 4 minus 3. Y equals 1. So this time I have a y-intercept that is different from 0, 0. With me so far? So now this is symmetric through that x equals negative 2 line, which means whatever I just plotted to the right, I should also have a reflecting point on the left. So I went, if I look at this graph, up 1, 2, 3, 4, and to the right 2. 4, 2. So I'm going to do the same thing in the other direction. Up 1, 2, 3, 4. And I'm going to go left 2. And I should have a coordinate point there. Now, if I'm just doing a fast approximation, I'm comfortable with that. But if I was doing this on a quiz or a test, I would definitely check to make sure that's right. So I would plug in negative 4 because that's where I think it's at, and I expect to get a positive 1. So if I plug in negative 4, I get my positive 1. So I know that this is my graph. Again, what you need is 3 points. The vertex, 1 to the right and 1 to the left. If it had asked for x-intercepts, we would have worked through that. So let's just say it had asked for x-intercepts. I would have then made the y 0, which is my f of x. It would say 0 equals x plus 2 squared minus 3. I would add the 3 to the other side. I would square root doing plus and minus. And then I would subtract the 2. And I'd get negative 2 plus and minus the square root of 3 as my x-intercepts. So negative 2 minus root 3, 0 is one of them. And negative 2 plus square root 3, 0 is the other one. So when when WebAssign asks for it, it will actually say give the smaller one first and then the larger one. You need to make sure it's in coordinate point form. Otherwise, it will mark it wrong. Like you can't just give negative 2 minus root 3 and negative 2 plus root 3?
Could you also like FOIL the x plus 2?
You can, but this isn't factorable, so then you'd have to use the quadratic. But you can. So the question, I don't know if you heard her at home, but she said, can you FOIL out the x plus 2 squared, combine your like terms, and then solve from there? The answer is absolutely. You just are going to have to use the quadratic formula, which sometimes you're going to have to use anyways. So it's completely up to you. You can either use the even root, which is what we just did on this one, or you could have expanded it, FOILed it, and then done the quadratic. You'd get the same answer. So if I was going to try to graph this, I would approximate like negative root 3 is like a 1.4. Actually, it's like a 1.7. So I would approximate that to be negative 3.7 and then negative 2 plus 1.7, which is approximately 0.3, negative 0.3. And if I look at my graph, negative 0.3. And if I look at my graph, this looks like it's pretty close to negative 3.7, and this looks like it's pretty close to negative 0.3. So it just confirms what we found, okay? Questions on that one? So this would be the second part of what the quiz question is going to ask for. It's not going to give it to you in this format. I'm going to teach you how to get it into that format. That's part of the process. It's called complete the square. And then you're going to have to find the vertex, the axis of symmetry, the y-intercept, the x-intercepts, and then you're going to have to graph it. So just keep in mind that that part is definitely part of what your quiz grade will be. Questions so far? Okay, so this is in what form? Quadratic or standard? Quadratic, because there's an x squared and an x. Okay, so I don't just pull the information out of it like we just did. This is my negative b over 2a. Does that make sense? So I'm going to start by identifying that this opens in which direction? Up. Then I'm going to find my vertex. So the vertex is negative b over 2a. This time my a is 1 and my b is negative 6, which means my vertex no longer 0, 0, right? And I can't figure out my shifts on this because it's not in standard form. So I don't know that horizontal shift or the vertical. None of that's going to help me yet.
Why would the b be negative 14?
So that it's ax squared plus bx minus c. So the c is the number that's by itself.
Oh, okay.
So now I get negative 6 over 2 times 1. And I get 6 over 2, which is 3. And that is the x coordinate of my vertex. Because it's it's negative b over 2a. So the negative came from the equation, and then the b is also negative. Take that and plug it back in. So I get 3 squared minus 6 times 3 minus 14, and I get 9 minus 18 minus 14, negative 9 minus 14, which is negative 23. You with me so far? So I don't want to have to graph all the way down to negative 23, okay? I'm just going to plot the point. I'm actually going to go by 2's here. So I'm going to change this so that it's negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. And I'd still have to get a little bit further. Zoom out. So I'm just going to plot a point. Whoa. Positive 3. So I can also go 3 and negative 2, 4, 6. Positive 3, negative 23. We're going to say like somewhere down here. And I'm going to plot it and label it because it's not on my actual graph. So you can go off the graph. Just make sure you plot and label it. Now I know this points up, so I've got points above it, right? But I got to find some of them. Standard form, it's harder to find the y-intercept than the quadratic form. Quadratic form, when I'm finding the y-intercept, I'm just plugging zeros in for x, so I'd get y equals 0 squared minus 6 times 0 minus 14. These will always cancel out. And I get the C. So that makes my life a little bit easier. I'll always get the C if it's in quadratic form. So that point is here. So because we went up, so if I go from negative 23 to negative 14, I went up 9, and I went from 3 to 0, I went left 3, I should get the same thing on the right-hand side. If I go up 9, which is negative 14, and go to the right 3, which would be 6, I should get a coordinate point there. So what happens when I plug in 6? 6 squared minus 6 times 6 minus 14, 36, minus 36 minus 14, and there's my negative 14. The axis comes from the x coordinate of your vertex. So this would be x equals 3.
And then that's how you know like which side to like
Yep.
divide
To go up and over, however many from that exact axis. So if it was graphed, it would be right through there. And again, if it had asked for x-intercepts, right? Like in this case, if it was factorable, it's super easy. If it's not factorable, which is there's no factors of negative 14 that sum to negative 6, then I have to use the quadratic, okay? So just know that you're going to have to do that part, okay? We'll practice it a little bit more, but no, you're going to have to do that part. Questions so far? Okay, what I'm going to do with you next is actually easier. That's the good news. So now we're working in reverse. I skipped, I don't even know what slide this is, 12 maybe? Which is taking the vertex and a point and then finding the equation from it. So when we do this, we take the vertex, which is the HK, we take a point, which is XY, and we plug it into our standard equation, which is y equals a times x minus h squared plus k. I will have all numbers except for one variable, which is a. I'm going to solve for a, and then I'm going to plug back in just the h, the k, and the a. Meaning, so x and y will be part of my equation. So my answer would say y equals, there will be a number here, x minus, there will be a number here, squared, plus there will be a number here. So the x and the y will stay as x and y, and then everything else will have a value in its place. So those look like these. The vertex of 1, 2 passes through 3, negative 6. So my vertex is my h and my k. The axis, the point is x and y. I'm going to plug it into y equals a x minus h squared plus k. So the y is negative 6. The a is my unknown. The x is 3. The h is 1. The k is 2. So I just plug everything in I know. Negative 6 equals, and then I solve it. 2 squared plus 2. And for some reason, I don't know why, it happens every year, people add these, okay? You can't do that. So this becomes negative 6 equals, this would be a times 4 plus 2. You cannot add the 4 and the 2. You have to subtract the 2. Negative 8 equals a times 4, then divide by 4. And a is negative 2. So I take and plug in just the a, the h, and the k. So I get y equals, a is negative 2, x minus 1 squared plus k, which is 2. If you had time, you could try to do that, like plot that using the shifts and see that it's consistent with your 1, 2, and your 3, negative 6. Okay, last one, and then we're going to stop for the day. Again, this would be my h, this would be my k, this would be my x, this would be my y. So y, which is 5, equals a, my unknown, x minus h, oh wait, I didn't do x, sorry. X, which is negative 6, minus h, x minus a negative 4, squared, plus k, which is 11. That minus the negative becomes a plus. 5 equals a times negative 2 squared plus 11. 5 equals a times 4 plus 11. Again, do not add the 4 and 11. Subtract the 11. Divide by 4. And a equals negative 3/2. Plug it back in. Y equals a, negative 3/2. X minus a negative 4 becomes plus 4 squared plus the k, which is 11. Okay, a lot of these are multiple choice. What I don't want you to do is look at those answers and then pick an answer. What I want, because these will not be multiple choice on your test, what I want you to do is graph them the way that we've been graphing them and then come back in here and make your pick, okay? So don't get a false sense of security by seeing an answer and being like, oh, that's it, and pick it, okay? Especially because a lot of these, if you just knew the vertex, you'd know the answer. You have to be really careful and make sure you be able to graph it from scratch. So at the very beginning, it says to write this in standard form. That's the part we haven't done yet. So skip that first step. Graph them like we've been graphing them. Fill in these answers at the bottom. Notice it says vertex, axis of symmetry, x-intercepts, that kind of stuff. Okay, and then pick your graph. Also remember that the axis of symmetry has to be an x equals. So whatever x equals h, whatever it has to be x equals, not just the number. And that the x-intercepts and the y-intercepts have to be in coordinate point form. So the x-intercept is going to be a number, comma, 0. The y-intercept is going to be 0, comma, a number. Okay? So otherwise it will mark it wrong for format. Please, 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 for the love of God, start this tonight. Okay? If you leave it all for tomorrow, trust me, it will take you a long time and then you're going to hate me more than you already do, and I don't want that to happen. Okay? I want you not to freak out. So you've got time right now, obviously, if you want to start it, if you're still here. And then if not, I would at least get started on it tonight so that tomorrow, and one, I can answer questions tomorrow, but also that it doesn't feel like it's so painful. So don't answer the standard part. When you get to